Hey guys, welcome back to another edition of Math with Matisich. We are moving on from categorical variables for a little while, and we're going to look at quantitative distributions. So where categorical, we were using bar graphs and pie charts, and if there were two variables, two-way tables, and maybe even like segmented bar graphs and such. None of those are really going to apply to a quantitative variable. So the distributions what we're going to look at today are dot plot, stem plot, histogram. Those are three different types of graphs. And then we're also going to try to describe the shape that these distributions can take. So without further ado, we're going to do the dot plot first. It is the simplest way to view the distribution of a quantitative variable. So I got some data here. I can show you where I got it from. Take me just a sec to get there. I went to ESPN. I was watching the Bayern Munich Paris Saint-Germain game the other day, and it just got me thinking, I wonder how many goals Bayern Munich scores. They got some awesome players on their team. So they played 11 games in the Champions League, and I just made a little tally of how many goals they scored in each one of those games. So hey, let me go back to our note page. If you have some note-taking devices that you can write these in, that would be great. So here are their goals in all 11 games. They scored 1 goal in one game, 3 goals in this game, 8 there, so on and so on. So I've got the data on all 11 games. So a dot plot, super easy to create. It's going to plot one variable. Our variable, of course, is goal scored. And so to make the dot plot, you're going to find the smallest value in your data set, which happened recently. They only scored 1 game during that championship game. So that'll be where your dot plot starts. And it's like, if you think about it, it's really just an x-axis. So we've got 1, and then it's going to go up all the way to the maximum value that happened in the data set, which is right here. They scored 8 goals one time. So I'll just start it off like right here. That'll indicate that they scored 1 goal, 2, 3, 4, 5, 6, 7, 8. I'll keep it going just a little bit longer. Again, 1, 2, 3, 4, 5, 6, 7, and lastly 8. Okay, so the dot plot, each dot is going to represent 1 data point by a dot. So hey, this axis, by the way, is goal scored. Definitely want to label that. Goal scored by Bayern Munich. I'll just give it a really easy title up here, dot plot for. I'm just gonna use their initials, Bayern Munich and UEFA, the Champions League, best of the best. Okay, so for your dot plot, you are gonna put 1 dot for each one of those values. So we've got, they scored 1 goal 1 time, and then how many times did they score 2 goals? Looks like it happened only once, so 1 dot would go there. 3 goals happened 1, 2, 3, 4, 5 times. Son of a 1, 2, 3, 4, 5. Did not plan that out well. Okay, hey, 4 goals. Did they ever score 4? Yep, 1 time. 5 goals. Don't see any, so you would not put anything there. 6 goals. Looks like that happened 1 time as well. They scored 7 goals 1 time, and they scored 8 goals 1 time. So they've got a big group over here, and then like a smaller group over here where they probably played like some lesser competition, like Chelsea or something. So that is really it for a dot plot. Not hard to do, very easy to create. Once we get into describing shape, it does tell you quite a bit. It helps with finding things that I'll talk about later in the week, like medians and interquartile ranges and stuff. So keep it in mind. The dot plot is super simple, and it's honestly pretty effective as well. So that's it. That's the dot plot. We'll move on to a stem plot, which is a lot more involved, kind of just not so easy to create. So we're going to look at a different data set in order to do that. I'm going to go to the stats survey that we took at the very beginning of the year. It should help us out. Okay, so I took 2 variables from the entire data set. I took gender and I took shoe size. These are the 2 variables I just copied over here, and I think would just make a a good point of what a stem plot is for. A stem plot, they can plot one variable or two variables against each other. You'll see what I'm saying. We're not actually going to plot gender per se. Anyhow, so a stem plot. Here is the basics of a stem plot. You've got stems and leaves, right? So here, a stem plot. They're going to look like this. You're going to have this stem, and then over here will be leaves. So this is called your stem, and then this section over here will have leaves on it. I think once we start to fill this in, it'll make a lot more sense. Right off the bat though, your stem, it's going to be the next to smallest place value. The leaves will be the smallest place value. So when you're looking at our data, I added the 10th place to everything. Like some people only wrote 8, but I had to write it in as 8.0 because I needed the place values to be common. Okay, so our stem is going to be the ones place value. So going from like 5 to 6 to 7 all the way up to like 11, we're going to stop right there at 11. And the leaves are going to include all the tenths values, like 0, 0.5, 0.0, 0.5, whatever, you know. Maybe we'll make, we'll just make one stem plot for now, and then we'll do a side-by-side one. So again, your stem plot, it's going to have a stem. That does not look good, but it's okay. And we'll go from the smallest value that we've got, which is 5, and then we'll go up to 6, 7, 8, 9, 10, 11, and then the big issue size we had was a 12. So then the leaves are going to get listed right here. We have got, all right, so in this stem, the shoe size of 5, I believe we only have one person there, right? Which was 0. So let's put a 0 there. Only one leaf fell into this stem. There's only one person in that kind of shoe size length of 5 that we're going to list there. For 6s, that was also one, but instead of 0, that smallest place value, it was a 5. Okay. For 7s, it looks like we actually have quite a few. We've got 2 zeros and then 1 5. So what this means, right, is 2 students have a shoe size of 7.0. One of those in this stem has a shoe size of 7.5. That's really just how these things work. So then for 8, you'd go 0, 0. These are all in order, which makes it a lot easier for you. 9, you have 0, 5, 5, 0. And you want to list these in ascending order. So even though we go from 0 to 5 to 5, and then it has like 0 here, you want to group the zeros together and then the 5s together. So we'll go like that. 10, 0, and then a 5 and a 5. 0, 5, 5. That was it, right? 3 people in the 10 stem, 3 leaves in the 10 stem. For 11, there's 2 zeros, and for 12, there's also 2 zeros. Okay, and that's how you really do make a stem plot. That's it. One thing that you're always going to want to do with a stem plot is include a key. People need to be able to interpret this. So our key is, you just pick one of your stems and leaves. So like we'll do 7. Key is 7, 5. 7, 5, what does that mean truly? That indicates a student wears a size 7.5 shoe. We just need to be able to make sure that people can interpret this stem plot. Not a lot of information here, but when you add a key, it'll definitely help. We can put like an S here for stem, leaf there if you wanted, whatever. So what I want to do now is make a back-to-back stem plot. It's made almost the same way as this, but it can compare different groups within the same data set. So let's make a back-to-back stem plot. So again, we're going to have a stem. We're going to have a stem, S, and then we'll have like males on this side maybe, and then females on that side. So our stems are going to be the same. They go from 5, 6, 7, 8, 9, 10, 11. And was there a 12? I think there was. Yeah, there's a couple of 12s. Okay, so what we're doing with a back-to-back stem plot is comparing different groups within the same variable. So we're still just looking at shoe size, but we're also splitting these up between female shoe size and male shoe size. So for females, we've got a shoe size of 5.0. So it might look weird, like nobody wears a size 0.5. So make sure you, when you're key, you always start with the stem value, right? Female 6.5, so that student would go here. 7, we got a 0, then a 7.5. For 8, we've got an 8.0, an 8.0, and an 8.5. For the 9 range, right, for the 9 stem, we've got a 0, shoe size of 9.5, and one more shoe size of 9.5. And that'll do it for the females. We got every observation for females on this side of our stem plot. So it's back to back in terms of we got one group here, the stem, and then another group here. So again, this is called a back to back stem plot. It's a pretty easy way to compare a quantitative variable. You dirty son of a. Let's go back to that spreadsheet, huh? Okay, here we go. What in the... All right, minor technological glitch there. Hey, so for the men, let's do them next, and we'll do them on the other side, of course. We've got 9.0. Let's put a 0 here. That's it for the 9 stem. We've got a 10.0, a 10.5, and a 10.5. So 0, 5, and 5. For 11s, we've got a 0 and a 0. And for 12s, we also have a 0 and a 0. Okay, so why is the back-to-back stem plot important? It can tell you something. I think you guys can probably deduce what I'm trying to get at here. If you look at these two sets, we have a group over here for males, and then this group is like way up here for females. So that should tell you that males typically have a bigger shoe size than do females. So again, you would want to include a key here, pick any value you want really, like you could do 11.0 if you wanted, and just write out in context what that value means. It's a stat student would wear a size 11.0 shoe. And that's it, that's the stem plot. They're kind of cumbersome to make, especially when they're not in ascending order like this. But again, they can tell you a lot of stuff as well, between groups, or even if there's just one variable, whenever we get into describing shape. So hey, let's move on to our last plot that we were going to create, which is a histogram. So let's go back to the note-taking devices. Let me get there real quick. Got a bunch of stuff in my way. I gotta get better at this, huh? Hey, so if we go back to this, we've got our stem plot done. Just remember, stems and leaves, the lowest place value are going to be the leaves. And that's another way that they actually call those things. Instead of a stem plot, they call it a stem and leaf plot. Anyhow, so the histogram is next. The histogram, it's a lot like a bar graph. And it is actually going to pull students into different groups or different ranges. So for Bayern Munich's goal scoring machine here, we've went from 1 goal all the way up to 8. And I think what I'm going to do on this one to make the data, typically you want at least 5 different groups for a histogram, but since our range here, it only goes from 1 to 8, we're just going to use 4 different groups. So I'll show you what I mean. Sometimes they're called bins, or even they're just called widths, and they're also sometimes called intervals. It's probably most common. So our first interval would be everything. It's going to include everything from 1 goal scored up to, but not including 2. Well, actually, we should include 2. So everything from 1 to 2. Everything from 1 to 2 would be our first interval. Everything from 1 to 2. Okay, and then our next interval then would be everything greater than 2, and then up to 4. Or just another way of doing that would just be if they scored 3 or 4 goals, they're going to be in this this interval. And then we would go from 5 to 7, not 5 to 7, 5 to 6, 4 to 6. Oh my gosh, 4 to 6. And then 6 to and up to including 8. Okay, that'll work. So what we're doing is grouping these goals into different intervals using frequencies. Frequency isn't kind of like a tally mark. So how often did they score between, how often did Bayern Munich score between 1 and 2 goals? We've already got our dot plot set up, so it should be pretty easy to create. That happened 2 times. And then 3 and 4, I could have done this a lot different, the intervals. How many times did they score between 3 and 4 goals? That happened a lot. That happened 6 times altogether, I believe. And then the next interval, which would have been 5 and 6 goals scored, that happened once. And then they scored a ton of goals, 7 or 8 goals. That's what this is really like, meaning 7 or 8 goals, they scored that amount 2 times. Okay, and then just to verify, we've got 2, 6, 8, 9, 11, which is what we were going for. Okay, the next thing that we're going to do is create the relative frequency. Histograms, sometimes they're displayed using frequencies, sometimes relative frequencies. So I'll just show you a relative frequency because it requires just a little bit more work and should give us a pretty good idea of how it's created. So I'll get a calculator up. And hey, so we've got this interval happened 2 times. 2 of their observations found in an interval out of a possible 11, so about 18%. The next one happened very often, 6 times out of 11, so you're looking at around 55%. More than half of the time they ended up being in this interval. Interesting. Then we've got 1 over 11, about 9%, and then 2 out of 11, again, is about 18%. And then there might be some rounding error to where this doesn't add up to exactly 100%, and that's okay. Make sure it's close or else you probably have an error. And that's really all you need to create your histogram. So we'll make the histogram using relative frequency, like this. So the histogram, it's a lot like a bar graph. You're going to have a y-axis in terms of frequency. So maybe I'll go like 20%, 40%, 60, 80, and 100. And then we'll have an x-axis, which is our number of goals scored. Number of goals scored. Okay. And again, this is relative frequency as a percentage. That's our y-axis. Relative frequency as a percentage. Okay. So our widths, we go up to 2 goals scored. So this will be the interval. Everything from 1 to 2 is included in this interval. Everything more than 2 but less than 4 goes in this interval. Nope, right here. Everything more than 2 but less than 4 goes in this interval. Everything more than 4 but less than 6 will go in this interval. Everything more than 6 but less than 8 will go in this last interval over here. So that's why I set this up that way. Anyhow, how often did they get in this first interval? It happened about 18% of the time. It's about right here. And it's just a bar. Okay, the next interval happened 55% of the time. So we're looking at around right here, a little bit more than half. Make another bar. Okay, very good. I should have scaled this a little bit different to make it easier to see, but it's okay. The next interval happened 9% of the time. It's about halfway up this first bar. It's the least common interval for them to be in. and the last interval was again 18%. So I said 5 groups. You usually want 5 groups. I just didn't have enough range to do so. Okay, that's it. This is a histogram for the histogram for goals scored. Maybe I can even put a relative histogram because we use percentages, not just frequency. So a relative histogram for goals scored. Goals scored by Bayern Munich. Awesome. The histogram definitely tells you a lot of stuff. It's probably the most common distribution that you're going to be looking at as we progress through the course. Just a couple things I wanted to add here. Histogram, like I said, you want at least 5. That way you can describe the shape a little bit easier. One distinction to make here, I know I talked about this in another video sometime. The bar graph, the bars don't touch. The bars don't touch. And a bar graph, a histogram though, if you have a histogram, certainly the bars are, I'm going to try to come up with a better name for that. They are adjacent. They are directly next to each other. Unless one of the intervals didn't have any observations whatsoever, you're going to have this gap. Like if this interval never happened, if the frequency was 0, there would have been a gap here. And you want to display that in your data. It's important. It never actually occurred. There was nobody in that interval. Okay, so the very last thing that I was going to cover with y'all, we've got a histogram made, a stem plot, and a dot plot. The very last thing is describing shape. And this will kind of segue into what you do tomorrow. So when you're describing shape, what you're going to be thinking of is, if I were to kind of just smooth this out and draw a curve around it, what does that look like? So if I would have went like this, it kind of comes up, then it comes back down, and then we've got another kind of little bump right here. So you're kind of smoothing out your data using a curve. So here's what the shape looks like. It goes up, goes back down, there's another little cluster down here. So for shape, there's a lot of different categories here. I'll just go through them all really quickly. So pretend I just made a dot plot. I made a dot plot. I put some dots up. I traced it using a smooth curve, and it looked like this. If your shape would have looked like this, like if it would have looked like that for the goal scored for Bayern Munich, this shape you would describe as being symmetric. Symmetric. Something symmetric when you can draw a line somewhere. It doesn't necessarily have to be in the middle, but certainly somewhere. And approximately half the data is over here, half the data is over here. You could flip one side on the other, and there'd be some overlap there. Like if I were to fold my paper over that line, those two curves would be on top of each other. That's called symmetric. That's one way of describing shape. Another thing that could happen, and what I would have expected to happen with like goal scored in soccer, is if we made a dot plot for teams, there's probably a lot of games where they're scoring like 0, 1, 2, or 3 goals. And then there's a drop off. There's not a lot of blowouts. They don't score a lot of goals a lot of time. And so if a curve ever looks like this, it has a name. It's called skewed. And skewed, it's either going to be right or left. To determine that, you're really looking at this tail. Is the direction of the tail to the right, or is the direction of the tail to the left? So this tail is certainly to the right, and you would call this distribution skewed right. The opposite of that, of course, is something that's skewed left. I'll show you what it looks like. Something that's skewed left is like, so your curve's going to be looking like this. A lot of high data values, and then the tail's to the left. Again, you're looking for things that tail to the left. This is called skewed left. So we've got symmetric, skewed right, skewed left. Okay, now we'll look at one more thing. Kind of going back to that stem plot that we created at the very beginning here. So For the shoe size, here would be my example. It's a shoe size. Shoe size would be, gosh, something like, there'd be a group here. There was a lot of people that had like a size 7 shoe, or kind of in that range. Kind of went down a little bit when we got to the 9s. And then when we looked at the male shoe sizes, it kind of peaked again at like 11 and 12, like that. So this thing, you have these 2 peaks. So this would be called bimodal. If there were 3 peaks, trimodal. And so like if we would have plotted heights for you guys, usually female heights would be like a lot smaller, or not a lot smaller, but typically shorter than the male students that I would have in class. So that's another distribution. That's it that I wanted to talk about today. Describing shape. So it's either going to be symmetric, skewed right or left. The histogram, you're grouping things into intervals, grouping quantitative data into intervals to where they kind of become categorical, where you're using frequencies. The stem plot, just remember the leaves are the smallest place value. Dot plots are super easy to create. And if I would have drawn a smoothish curve, we've got this giant peak up here, and then it really tails down to here. So this one would probably be skewed to the right, because we have a lot of data points over here that's kind of dragging this tail this way. So I would certainly describe that as skewed right. This one, if I was describing the shape, and if we just got to admit these ones weren't really here and they fell into like one of these categories, we would probably say it's mostly symmetric. You don't really want to say mostly, you would say roughly, by the way. Okay, that's it. Well, for skewed left, an example here is actually like grades. Grades are actually typically skewed to the left. You have a lot of high performers in this AP classroom. There'll be some people getting B's, and very rarely, if you're taking this class and you keep with it, you're going to be failing. So there's an example for that. Okay, hey, I'm going to go ahead and stop this video now. Thanks y'all for watching, and I'll see you in class sometime. Goodbye.